Okay, welcome everyone. This is Double Canopy. I'm Joe, and today we have Dr. Rebecca J. Cole and Dr. Rakan Zahawi, also known as Zach, if that's okay to call you Zach. Okay. You're both incredibly accomplished scientists, ecologists, teachers, and leaders. I don't know where to begin with your introductions. I'm reading your CVs and your experience and your resumes, and it's dense, to say the least. Can you both tell me what you're up to at the moment?
Sure. Currently, I'm a restoration ecologist working with the Crowther Lab at ETH Zurich. I'm collaborating with nonprofit organizations across Central America, looking for better ways to restore forests to degraded land. And I'm also a restoration and conservation practitioner. I have a farm in Costa Rica and have been working for quite a few years to restore forests to degraded lands in that area.
I'm based in Galapagos at present. I'm the executive director of the Charles Darwin Foundation. It's a research institute dedicated to doing research that helps better conserve and manage the Galapagos Islands and the Eastern Tropical Pacific. I'm also a restoration ecologist and have projects in Costa Rica, mainland Ecuador, and elsewhere in Rakan, collaborated.
This is kind of a full circle episode for me. My first interview on this show was with Timothy Truer and John Choi. Did you guys ever meet them in Costa Rica?
Yeah, we actually worked with Timothy Truer, do a survey that's currently not published yet, but to look at uses of coffee pulp across Central America. And I know their names from the earlier work that they did on Dan Jansen's project.
Very cool. Yeah, so I can't remember when I first saw that. It was probably in 2017 when the paper came out. It was a huge inspiration for me, and they mentioned you guys and what you were doing with coffee pulp 2 years ago when I first talked to them. Can you tell me what the story is behind your experiment, the coffee pulp experiment?
Similar to what you just described, I was also inspired by Jansen's work actually at the very beginning of the Orange Peel project. First visited that site in 2003, was only, I think, a couple of years after the restoration program was stopped. And I just thought it was one of the most amazing ideas, so simple, but yet so applicable in so many different ways. And the story behind that project and how it sort of came to a grinding halt, and then very little data came out of the project. The paper you're talking about is one of the few. And then also, of course, it wasn't really applied anywhere else. So it stuck in the back of my head. I was based in Costa Rica for almost 15 years, and I always wanted to do something along those lines and revive that work. And Rebecca and I talked about that, I don't know how many times, in various field settings, and then did a trial, and Orange Peel didn't make sense where we were based, so we thought, well, what's another waste product from agriculture that's produced en masse in the area where we were working in, and coffee rosa, or coffee pulp, was the obvious answer for us. And so we talked about it, but neither one of us really had bandwidth to do the project. And then eventually, we did a small study, which was a miserable failure. An interesting thing with waste is, and Jansen certainly didn't have this issue, is you have to apply enough so it doesn't turn into an immediate fertilizer. So the first thing we did was we wound up fertilizing a little patch of grass, which became extremely green and happy and grew enormous in a short time span.
I see.
So to expand what we were doing and the quantity we were applying to be increased, and that took us maybe 2 or 3 more years before we actually got around to scaling it up enough to have essentially the same outcome as what Jansen had.
Does that sound about right to you, Rebecca?
does. Yeah, we did as Zach was mentioning, we did a trial. It was too small a scale. We didn't add enough coffee pulp, and it didn't give the results we were looking for. But when we finally scaled it up, we just got this amazing response where forest essentially just started growing back on this very degraded land.
So you had
Go into more details on that later.
Yeah, you had about a half meter on the main experiment. How deep was the first experiment that you guys did?
Oh, maybe 20 centimeters, something like that. It wasn't enough to smother the grass. So one of the biggest barriers to forest recovery in this part of Costa Rica, where both Zach and I have worked for 15 or I guess closer to 20 years now, is these non-native pasture grasses will establish, and they'll just not let any seeds, like tree seeds that fall there, actually germinate and grow. They outcompete them. So
Right.
coffee pulp smothered the grass, and then seeds landed on the site and grew and had that space and had lots of nutrients to really take off.
Hmm. And on the main experiment, and I don't know if I asked this about Dan Jansen's project, but did native grasses come with the trees when it was regrowing after the application?
There are some native grasses. They're not that common. So, no, we didn't really see any native grasses coming in. Maybe Zach has a better answer to that. But what we really saw was some other herbaceous species starting to establish. But the most dominant thing that established on the coffee pulp plots were woody species, which is exactly what we were hoping would happen.
Yeah.
Yeah, I would say, we focused a lot of our surveys on the woody vegetation more so than the herbaceous, but under pasture conditions, you're not going to have many native species of grass in there, and because they get out competed, but they would come in under a forest canopy situation. One other key piece of the smothering is also the baking, and in Guanacaste, where Jansen worked, you have a 6-month dry season, and so when you spread half a meter of orange peel waste out there, it really has a chance to bake and essentially cook the grass and the roots, and so there's really little recourse for regrowth or for seeds to germinate. And in our first study, if I'm not mistaken, it started. We have a much smaller window of a dry season, and where we work, it's only about, in a good year, it's 3 months, and in a bad year, it can be as short as a month. You need to catch that window to help. At least that's what we think, because basically, if it starts raining, we start having a very quick, rapid breakdown of the organic matter, pulp, and of course, the rainfall creates channels and so on, and before you know it, you've got the grass coming back, and that certainly happened first pilot study.
Interesting. You said coffee was the main ag product in your area. Was there anything else? Were there any other ag operations? Did you consider the nutrient composition of other waste products, or was it, just basically you were looking at what you had around you guys?
For our purposes in this region, coffee is really the main agricultural product that would have a byproduct that was usable. But nearby, there are oil palm plantations. They're producing a lot of waste, sugar cane, or other things that come to mind in Costa Rica. And in other areas, of course, like fruit production, like orange peels. But for our purposes, coffee was really the only option in this area. That was the best choice for us. You had mentioned the nutrient composition. Coffee pulp is incredibly nutrient rich, and it probably a little bit more so than orange peel or orange husks and palm fruit from what I've seen.
More protein, especially?
Yeah, a little bit more protein, just overall more nutrient dense.
Did you guys ever consider mixing waste products? I know, I love the idea of just the visual of dump trucks, right, with one thing straight from the factory, just smothering a pasture. it would take more work to mix waste products together. But did you ever consider that?
I don't think so. I don't recall us ever talking about it. I think a key piece of what our project sought to do, and same with Janssen, is practicality, and just trying to be, what are the core barriers, and as Rebecca kind of outlined, the aggressive grasses are one of the slower things to remove by other mechanisms. I mean, once you have shade, then their competitive ability is weakened. But if you're going to plant trees and try and get them to grow in this environment, we're probably looking at a better part of a decade before you get, or at least five years or so before you get enough canopy cover to where you start seeing that effect. And meanwhile, you need to be overseeing that. Whereas this is, as you said, basically a dump truck and a tractor spreading the waste, and you're done.
I will say the pictures I saw from your plot were much tidier than the orange peel plots. You guys had a tractor.
Yes, and it was a much smaller
so
plot. It was just a much smaller plot. So
I was gonna say exactly that. I mean, we were dealing with a much smaller volume, but you were just mentioning using other waste products and other amendments. So one of the things that is a natural follow-up to this study is, okay, so this work, is there a way to make it more scalable? Is there a way to use less so that we can maybe have a similar effect across a broader landscape? And we have been doing a follow-up study where we're testing different types of amendments. Unfortunately, we haven't been able to test oil palm waste or some of these other ag waste, but we have been comparing composted coffee pulp, which is much more compact, much easier to distribute, with other types of soil amendments, like adding elements of the soil microbiome, following standard forestry practices, and so on.
Mm-hmm.
So we're having some kind of cool outcomes from that too.
And you're doing that right now?
Doing that right now. In fact, I just got the results and I'm just starting to work on the data.
Oh, wow.
So
That's exciting.
Very excited to see what we're getting.
That's terrific. And how big is your plot now?
We're working across a bunch of different sites and with multiple different tree species. So we're testing this on planted tree seedlings. The most cost-efficient way to restore forest is just to let it grow back by itself, but oftentimes that will not happen very quickly on the time frame that we sort of want to see. Mm-hmm. So planting tree seedlings can also be very effective. There are many species that if you plant them in degraded soil, they don't grow well. Sometimes they don't even survive. So what we're doing is we're using coffee pulp and other amendments to add to this very degraded soil in small amounts to see if we can actually get native trees to grow better, to grow successfully. Mm-hmm.
Mm-hmm. And
so to answer your question, how big is the plot? I guess we have about 3,000 tree seedlings planted over 3 hectares.
Wow, terrific. So that's about 9 acres?
Thereabouts.
Yeah, okay. 3,000, that's pretty dense. Your paper mentioned quantifying major barriers to forest regeneration in this region. You referenced another paper from Hall in 1999. I didn't read that paper, but what were the major barriers to regen? Was it mainly the grasses?
Well, grasses is a big one. Dispersal of seeds is another major barrier, certainly in big open expanses. So areas that are open without much structure in the form of trees don't attract frugivores, mostly birds, but potentially also bats and others, to bring seeds of trees into the landscape, and so you have a lack of propagators. Microclimatic conditions are also a major barrier. The conditions in an open field are usually much more intense, and a lot of tree species just don't do well in that kind of environment. When you have large-scale disturbances in tropical systems, you usually have a suite of pioneer species that can come in and do well, and they create the platform, if you will, for other species.
And that's like a micro canopy to provide shade for seedlings and whatnot?
a small canopy. I mean, it's not a big emergent forest canopy, definitely smaller in stature, but it just ameliorates the conditions such that more sensitive species, if you will, can establish in the understory.
Would one strategy be to be at the edge of the forest and sort of push out over time?
Yep, absolutely. I mean, proximity to forest is considered sort of a really important consideration when you're looking to restore a particular region in terms of prioritizing areas, because you would assume or expect that a patch of forest nearby is going to be a good, important source. Key to that, though, is knowing what's in that forest and that it's not been heavily logged or degraded such that you don't actually have a really good species pool.
You were inspired by the Jansen and Howwax experiment with orange peels and knew the outcome of that. Was the main idea simply to see if it could be done with something else? Coffee pulp?
I'll jump in with that. I'll say this was really Zach's idea. He's always, since I've known him, been really fascinated by that project. And I guess disappointed that there hadn't been a follow-up. So, there had been conversation for quite a few years that it would be really cool to do a follow-up. And I think that was kind of giving credit to Zach for really kind of pushing forward the idea of duplicating or replicating that idea.
Terrific. Yeah, I feel the same way. I wish I could do it.
Well, and I'll add to that since then, and this is sort of Rebecca thinking more broadly is sort of, okay, well, we can do it with coffee here. What about doing it with palm oil waste in the lowlands? And so we have, the seeds of maybe next generations or next iterations of this that, given, again, our bandwidth, we haven't really followed up on. But I just think there's few, or I think we both think that there's few. There aren't that many clear-cut examples out there where you can say, okay, industry is going to pair up with a bunch of restoration yahoos, and they're going to do forest recovery at scale in different areas. I mean, Jansen's idea took it even a step further, which was part of the downfall of the project, but conceptually it was amazing in that the conservation area in Guanacaste had tens of thousands of hectares of degraded land that had been purchased, acquired, folded into protected habitat, but it was trashed. Mm-hmm. And it wasn't going to recover overnight there in particular because it was dry forest as well. And so he had this agreement to dump the waste in the national park, which is, of course, what wound up creating all these legal problems within Costa Rica. But there you have an industry that could sort of attach a check mark on its label and say, we're helping to restore habitat in a national park. Nobody's going to, theoretically, nobody should be unhappy with that because that's the purpose of this land. It's not going to be developed into a parking lot or to some urban area. And so, having that win-win is just quite elusive, and I think there's enormous potential for this, especially with the scale of restoration interest today.
Yeah, that begs the question about industry and their interest in something like this to grow their next crop, right? If you're talking about forestry, you would think they'd be very interested in this. Did you guys see any interest from the forestry industry about being able to number one, regrow faster, healthier trees, bigger trees, right?
My part, I haven't had any contact from the forestry industry. I tend to feel that it's already very far along in terms of what they feel that they need to do to produce trees quickly, and I know it depends a lot on chemical fertilizers. But to take that question in a slightly different direction, I've been talking with quite a few people in the coffee industry over the last few years, and folks who are looking at sort of zero waste, moving to zero waste production in coffee. And there's a ton of interest in looking at ways to repurpose uh, waste from coffee grounds to coffee pulp. You might know that coffee pulp has tons of different uses. Some of them are very specific. You can make simulate leather. There are all sorts of medical products and cosmetic products. It's turned into various different types of food. I was talking with someone who said that their coffee shop was actually using it to make chai. But when you actually look at the amount of coffee pulp that gets used for these other market items, it's only about 20 or 30%. And then
The rest is
either
probably glue.
composted or just kind of left.
Yeah.
Yeah.
Yeah, I saw an interesting coffee pulp product. It was, or I'm sorry, used coffee grinds. It was, they put a bunch of binders and glue together with that and made coffee cups out of it, which is pretty cool. But a lot of glue, right? It's, like you said, 20% coffee grounds and 80% glue.
Yeah, or just from coffee pulp that gets used for many other things, but not all of the coffee pulp. Like it has many uses, but when you actually look into like what percent actually gets used, it's a lot less than what's actually produced and what's actually left at coffee producing sites.
Hmm. So I wanted to ask you too, how did you settle on your site?
Zach, if you want to speak to that one.
From what I recall, and jump in if I'm misrepresenting it, but one was a practical. I mean, there weren't. I guess now that I think about it, there were a number of things we had to look at. We had to stay a certain distance away from streams and from creeks, and so that was one consideration. There were a lot of logistics and legal issues around dumping coffee waste in as it turns out, after we did a lot of surveys in many countries in Central and South America, only Costa Rica has this scale of limitation, and Rebecca can speak better to this than I can. But that was one consideration. In the end, we wound up selecting this particular site because it was the site where coffee waste was already being dumped by the company, and they had basically large holding areas where they would come in year after year and put more and more coffee waste in there, and would eventually sort of seep into the ground and do its thing. Some of it would be turned into compost and sold, but a lot, there's a big area there where it was left, and so we selected a site that was near that, so that the cost of moving the product wouldn't really change for the companies, and then we defined the perimeter and outlined it, and then asked them to place the bulk in a particular location and box track that.
So it was owned by the coffee company, the land?
Privately owned land that was being, I don't know if it's leased, correct? No.
It's actually it's a private forest reserve for the community. And so the owners were very much interested in supporting research and restoration. And since they already had a permit for a nearby part of their property to receive this coffee pulp, it was very easy, and we didn't have any trouble with permits or anything like that. But this is a major consideration in Costa Rica, as it turns out, and almost no other country. They have very good laws regarding waste management, and coffee pulp is considered a waste product, so it's not entirely trivial to just put it out on a degraded site in Costa Rica.
Right. So how did you guys navigate those laws and restrictions? How long did it take?
Mhm. So in this case, we kind of got around those laws and restrictions because we were working at a site where that had already been permitted essentially for coffee waste disposal. But having looked into this much more extensively, to do this at other sites in Costa Rica, it has to be a certain distance away from a river. It has to be a certain distance away from houses. It has to be accessible by dump trucks. So there's a limited of the landscape where you could actually put coffee pulp out, or it would be practical and where you could get a permit to do this. And there's a governing body that will, you go to and you say, hey, I want to do this, and they'll come out and inspect it and make a decision as to whether it's a practical to do at that location, or whether it's not going to have any negative potential health effects.
I imagine they were curious about what you guys were doing and the success of past projects, right? Jansen's work. I mean, did you tell them, and were they excited to see what you were up to? The inspectors.
We shared we certainly shared the information with them, and they were directly involved in looking at other sites. Some of our collaborators, other nonprofit organizations are using the same method. And so it helps for the inspector to have this prior knowledge of exactly what we're up to. And, why we have crazy people deciding to put coffee pulp out on pastures.
Yeah, I don't think you're crazy. Yeah, I'm in the United States. I'm in California. We have tons of laws, regulations, restrictions. Every time, I don't even know how difficult it would be. It seems like it would be extremely difficult to do something like that here at scale.
Well, what was interesting is we ran into a lot of roadblocks we wanted to do some more expansive studies with this methodology in Costa Rica, which is where a lot of our work is based. But we did do some sleuthing on the side and had a consultant work with us to assess the laws in several other countries. I alluded to this earlier. And it turns out, at least for South America, I can't remember if did we do other countries in Central America, or was it just South America?
Other countries in Central America, but few other countries have as clear laws regarding environmental waste, or waste products, I should say, not environmental waste, but waste products.
Mm-hmm.
So in other words, doing this at scale in other countries would be far more feasible.
And I guess I want to clarify it. There are actual very valid concerns with putting this very nutrient-rich byproduct without composting it, without processing it. It was very effective in this case, and using it to restore degraded lands is a much better use than just stockpiling it or dumping it, which does happen in some places. However, I think that there's a lot more steps that need to be taken to really refine this and make sure it's safe and it's scalable. So this was a great proof of concept, but at least for me, the next step is making this scalable. We're now testing this with composted coffee pulp that does not have any negative environmental consequences. We apply it in much smaller amounts, so there's going to be less of a legacy effect of that on site. Just to repeat myself, that it was a proof of concept, but I think we need to take it to the next level now, and come up with something that actually is very, very scalable and usable and implementable across different regions.
All over the place. Yeah, the thing I think about is exactly right. They dump it somewhere, right? That's been happening since industry has begun. Coffee, bananas, oranges. Whatever industry there is, there's a waste product and they put it somewhere. It's just, if it's sitting in a lot somewhere, it's not being as beneficial as it possibly could. The thing I think about is, like I brought up the idea of mixing other waste products in with, the main one, but also mixing it in with the soil. So maybe to, add not just volume, but a neutralizer to some of these really dense products or nutrient dense products. And big machines can turn that stuff and mix it up and spread it out at enormous scale. That's my dream anyway.
Yeah, absolutely. So Garasu Coffee in Costa Rica is doing an amazing job with recycling coffee pulp or repurposing it. They do compost it. They have a very mechanized process for this. And there's some recent research looking at emissions from different methods of composting, and exactly what you said. If you add plant material and some other organic material during the composting process, it can really reduce the level of emissions from that. So I think, each within industry there are a lot of improvements being made in terms of handling the waste. That just needs to be moved beyond the case study or the one example, and become more of an industry-wide practice.
By the end of 2 years, the layer of coffee pulp resembled the underlying mineral soil and had reduced to 5 to 10 centimeters depth. So you went from half a meter, 1.5 feet, to just 10 centimeters. Was this due to natural settling, critter activity? Was it a transfer of mass to the vegetation, the trees itself?
Yeah, so essentially the coffee pulp was breaking down. So this is an area that gets about 3 to 4 meters of rain a year. So things decay extremely quickly. So the coffee pulp was composting. It was being broken down by bacteria and insects and fungi. And yes, of course, some of it was being absorbed by the trees, but it reduced in depth just quite dramatically.
That's incredible.
And absolutely changed the soil in that area. If we compared it to the soil in the adjacent areas that where coffee pulp had not been added, you could just see a huge difference in the soil. The degraded soil had a lot less organic matter. It was much more nutrient poor compared to the area that we had put the coffee pulp.
And was it the underlying soil when you got there, was it compacted at all, or was it pretty spongy?
No, it was quite compacted, and that's very typical of degraded soils. I believe that this was an area where forest was not going to be growing back quickly on its own, and I'll have to look at my data, but the soil was definitely degraded, low nutrient, fairly typical
And with
of agricultural land.
And with the trees that did get established, did you have an indication of how deep their roots went? Did they stop at the compaction layer or hard pan at all, or did they break through?
Yes. And I don't know, Zach, if you want to feel that one. We actually didn't do any root excavations, but I know that those trees did not send their roots down very deep in many cases.
But they did well.
They did well. They certainly were deeper than past the organic matter layer that was created by the coffee pulp. The thing that was amazing to see here is a lot of the species we had, the vast majority of the recruits, the individuals that came in, were early successional species, were pioneer species. That is what you expect in a recovery process. But you move that process on steroids with this addition, with this treatment. Whereas in the control system, which was right next door, I mean, there was a little buffer area separating the two, and then there were maybe 2 or 3 individuals that had recruited, or maybe 5. Whereas we have to actually subsample in our plot because there's just so many individuals that recruited. So it really just rushed through what would otherwise taken maybe 10, 15, 20 years to get to the other side. Easy.
You mentioned the coffee pulp treatment had nearly 30-fold greater mean basal area. And I'm a little embarrassed I'm not embarrassed looking up new terms and phrases and words, but I struggled with this concept a little bit about what basal area is. I think I know now, but if you could explain.
It's essentially the same as a diameter measurement, except at the base of the tree.
But not at the ground level, a little bit like knee or knee high or waist high. Is that correct?
No, usually it would go down pretty low, and you would often do that in areas where you have a lot of trees that are still young, and so you don't want to miss that measurement. And it's also another way of basically saying how much ground is occupied by tree.
Mm-hmm.
I
Okay,
guess a forester would call it board feet, but you know,
board feet.
ecologists call it basil. Yeah,
Okay, board feet.
diameter. Yeah.
Explain that.
Well, I actually don't know the conversion there, but anyway, it's a similar idea of just, you're talking about how much of the area is covered by tree.
Gotcha. Board feet. Okay. Footprint, something like a footprint, tree footprint. Okay. That's all my questions. I do, I like to dream. I like to speculate. I know you scientists don't, maybe you do, but in my experience, getting people on a call or on a recording to speculate has been a little tricky. But I don't know if you guys have heard the, what's it called? Investing in Regenerative Agriculture podcast, I think it is, with Cohn. But he, at the end of every episode, he asked people if you had $1 billion for an ecological restoration project, what and where and why would you do it? And would it cost that much? Would it cost less?
I'll defer to you for the first crack at this question.
Well, I think we're there in restoration, in the sense that there's suddenly we've gone from doing these little postage stamp projects, and as grad students and early career scientists, when we were working in the field, getting funding for restoration was a huge struggle, and nobody even really thought about, well, how do we apply this across an entire landscape? And now that's actually the vexing problem in restoration. And suddenly there's this flood of money from multiple sources to apply this to mitigate climate change, to increase habitat, whatever the sort of longer objectives are. And suddenly our scientists like us who I mean, we do sort of daydream, but we weren't thinking about well, how would this work at the scale of hundreds of hectares or thousands of hectares, and suddenly you're thrust into this. And there's been some poor decisions made around that, and some good ones. But I think I certainly like to dream that this kind of application is exactly what you could do at scale, and what I think Jansen was hoping to do 20 years ago in Guanacaste. I mean, that first dump, and it was, I think, 3,000 truckloads or something like that, I can't remember exactly, was just a first pass. He was going to keep going until the whole thing was shut down. And I think that's where we really need to go. We need to see how do you, of course there's an environmental footprint that this causes, but it's a one-off, and the return is so much greater. So you do need to do some testing. You obviously don't want to pollute people's waterways and have an entire town infested with flies because there's 1,000 dump trucks of coffee waste just outside the town limits. But
from what I understand, the flies are temporary.
Exactly. And then we can create a buffer zone there. So I like to dream that some of these tools that we've been testing, the next step would be to really apply them at scale. And $1 billion is a lot of money, but the scale of the problem we have globally is probably well beyond that.
Sure.
And, I mean, I have other manias in restoration, but we have to talk about them. So I'll stick those for now.
Oh, please don't.
Well, I mean, I also love working with vegetative propagation and tropical systems. We have a lot of, well, not a lot, but a number of trees that can be propagated vegetatively using large cuttings, 2 meters, 4 meters, basically a tree that you can stick in the ground. And so again, that's another area that I played around with a bunch that could also be applied at scale, because you're basically working, circumventing the seedling stage. But a lot more work needs to be done.
Yeah. Rebecca?
Well, I won't give as articulate or long of an answer as that, but with assuming that there were more resources to put towards restoration, and essentially reforesting degraded areas, allowing native forests to grow back, conserving biodiversity. That's also one of the key desirable outcomes of restoration. I think I don't think there's one solution. I think this is a solution, but we really need 1,000 different solutions for different areas, across the globe. So I personally would want to do a lot more research. I think that actually subsidizing farmers, landowners that are doing really good jobs is another way to move towards these goals of restoration and conservation of biodiversity.
Mm-hmm.
So probably $1 billion would be a nice start.
Yes, definitely. Well, I want to thank you guys for joining me today. It took us a minute to get here, but man, I just love talking to you guys. And again, I'm hugely inspired by your work. It's going to definitely stay with me, just like Jansen's work did. So thank you.
Thank you,
All
Joe.
right, thanks. Nice talking with you.